Section 1.3 is going to be about this idea prime factorization. Prime factorization. And so when we talk about this word factors, we really want to understand that it is a number involved in a multiplication problem. Okay? And so let's take a look at number 17. Okay, and so number 17, the instructions say, list the factor pairs of the number. So on number 17, the number is 15. So a factor pair is a number it's a pair of numbers, and so that's going to be two numbers that you can multiply to give you that number that is listed, okay? And so it's only two numbers because it's a pair. So what two numbers can you multiply together to get 15? 3 and 5. Okay, and what we want to do is stay away from the number 1, because any number times 1 will give you that product. So when we're talking about factor pairs, we're talking about numbers other than 1, okay? And so listing the factor pairs would just be 3 and 5, and that would be our answer. Okay, so 3 and 5 are factor pairs for the number 15. Okay, so that's pretty simple. So what you're going to do is you're going to look at all those numbers and you're going to figure out what two numbers can you multiply to give you the number that is listed. Okay. So let's just move on to the next one. Let's go to this next set here. So the next instructions say, write the prime factorization of the number, okay? So now we have these two words, prime factorization. So what we're going to do here is we're going to write the number, and I would give yourself some space, okay? So we have this number 16, which is question number 33. So when you have this number, we're going to start building what's called a factor tree, which maybe you've seen it before. So a factor tree, you use this little symbol, this little sort of semi-arrow or this semi-triangle. And what you're going to do is you're going to list the factors involved in getting that 16. And so it can be a variety of numbers sometimes. So what you want to do is stay away from the number 1. You can imagine if you used 16 times 1, and then you did another factor tree here, 16 and 1, you would just keep going. And so what you want to do is stay away from factors involving the number 1. So let's think about some other numbers that you can multiply together to get 16. And hopefully you've figured out that it is 4 and 4. Okay, so 4 times 4 will give us 16. Great. Now what we try to do is we try and keep going by adding these symbols to the number that we've written down next. And we asked ourselves again, what two numbers can we multiply to get that new number? And again, we want to stay away from the number 1. So what can we multiply together to get 4? And hopefully it doesn't take you too long. That's 2 and 2. 2 times 2 equals 4. And it would be the same two numbers for the other 4. So now our factor tree is finished. And the reason our factor tree is finished is because whatever factors we're going to find for 2, it only involves the number 1. And whenever you only have the number 1, that means your factor tree is finished and you don't even want to write those two factors. So you're going to stop there. So now what this tells us is, this tells us that 2 times 2 times 2 times 2 is 16. Okay? That's essentially what we have found out. Okay? And a simpler way of writing this is by using an exponent. So remember from section 1 in this unit, 2 is the base, the number that is repeated, and it repeats 4 times. So this is a more accurate way of writing all of that stuff. And so when you can, use exponents in your final answer when you are writing the prime factorization of a number. Okay, so this is the answer here. This 2 to the power of 4 would be the answer to number 33. Okay, let's go ahead and do one more, just so we really have a good idea. And this will be the last thing we're doing in this video. So let's take a look at, let's just go to 34. So 34, we're going to find the prime factorization of the number 25. So what two numbers multiply together? 5 and 5 times 5 gives us 25. And I asked myself, can I come up with any two numbers other than 1 to get to 5? And this is whole numbers, okay? We're not using decimals or fractions. And you'll notice that the only two numbers involve a 1, which means we're not going to write it, okay? So we sort of stop right there. That means 5 times 5 is our prime factorization, and I want you to write that with an exponent. 5 is the base, and it comes up 2 times, so 5 to the power of 2 is my answer to number 34. Okay, so that is prime factorization. Coming up with the smallest numbers in a factor tree that multiply together to give us another number. Hope that helps. That was section 1.3, prime factorization.